Greetings, CTM students, and welcome to the lesson for 12.1. We are talking about probability now here with chapter 12. So here's some new vocabulary to learn by the end of this lesson. Make sure you know what those different words and phrases mean, and make sure you're using those extra examples in your book as always as we go over stuff here. But let's get started with some definitions first of all. So what is probability? We have to know a few other things before we can really talk about probability. And so one of those things that we need to know about, is an experiment. What is an experiment? So oftentimes you'll run experiments and then base your probability off of that. It's a controlled operation that yields a set of results. Controlled operation that yields a set of results. So that's what an experiment is. Outcomes. What are the outcomes of the experiment? It's just what happened. So what happened in the experiment? It's the possible results of the experiment. The possible results of an experiment. And then an event is one of those possible kind of subsets that happen. So an event is a subcollection, in other words, a subcollection of the outcomes of an experiment. So let me put this into a certain context for you. Let's say our experiment is flipping a coin, a fair coin. We're going to have heads and tails. So our experiment is, the controlled operation is the flipping of the coin. It yields a set of results. Those results can either be heads or tails. Those are the possible outcomes of the experiment. And an event could be, the subcollection could either be the group of heads that you got or the group of tails that you got. So that's putting it into context, into a workable framework, you might say, or something that helps you understand what all those mean in context without writing that all down. So now moving on to empirical probability. Empirical is kind of a fancy way to say experimental. So if you actually do an experiment, if you actually do something like that in order to calculate probabilities, what is the empirical or experimental probability? Another way to talk about this, or another phrase for this, is relative frequency. What's the relative frequency of something occurring within an experiment, within empirical probability, in other words? I'm going to underline all this. This is going to be the big kahuna for this lesson right here. So I'm going to circle this, leave some space down here to write some stuff in. And so P of E, this just is standing for probability of a certain event occurring. So the probability of an event occurring is the number of times an event E has occurred, putting that on the top, over the total number of times the experiment has been performed. So that's kind of the technical definition. What this really boils down to, though, is what I'm about to write here. If you can remember this, you basically can remember how to do probability, the basic gist of it at least. What it all really boils down to is what you want on the top over the total on the bottom. The number of ways what you want can happen over the total number of ways that the thing can happen overall. And so what you want over the total is really what it boils down to, but you need to have that within context of something like this. So this is good to know, but this is really what it boils down to, what you want over the total. Alright, so let's check out an example And let's say that this is the case. Suppose a fair die is singular for dice, so if you had more than one, that would be dice, but one is just a die. Suppose a fair die is rolled. We're not actually going to do this. This would take way too long, I think. 500 times, though. So suppose this die, fair die, rolled 500 times. And we're also going to suppose that 86 of the rolls resulted in a 6. So we're assuming this fair 6-sided die. You can actually have other dice. You can have other dice too that would be fair, but 6, a cube-shaped die is most common. So we're using a cube-shaped die. 86 of the rolls resulted in a 6. What is the empirical probability of rolling a 6? So in other words, what's the chance of that happening based on the results of the experiment? So this is empirical, this is experimental probability. Not just in general, what do we theoretically think? We're going to talk a lot more about theoretical probability. Yeah, we would say, if it was fair, you would say 1 out of 6 theoretically, but experimentally, empirically, based on the results of this experiment, what is the probability of rolling a 6? So in that case, if we're talking empirical probability here, we would say what we want was 86. There were 86 sixes out of the total was 500 different possibilities. We rolled it 500 times. So what we want was a 6. There was 86 of those out of the total number of times we rolled it was a 500. You could reduce this. You could divide both by 2 and get 43 out of 250. That would be a reduced fraction. If you're going to write this as a decimal, put this into a calculator, you end up getting, I'll bring up the calculator here, and you have 43 divided by 250. You could have done straight up from 86 divided by 500, you get the same thing either way, so 0.172. If you write that as a percent, sometimes you'll be asked to write probabilities as percentages instead, so any one of these answers I would say would be acceptable. It just depends on the way they ask you to state it. So that's it. That's all you have to do for something like that. This is the chance, the likelihood, based on the results of this experiment, of getting a 6. Let's check out a second example. So let's say we had a survey, and people were surveyed whether they liked cheese pizza compared to pepperoni pizza. So let's write down our results of the survey here. Of a survey of 1,000 people, 264 preferred cheese pizza and the rest preferred pepperoni. There we go. And we're going to find the empirical probability based on the results of our experiment, our survey. Find the empirical probability that a person preferred, be nice if I could spell, let's see, preferred, there we go. Part A, we're going to say cheese pizza. So what's the chance based on the results of the experiment? We just pick somebody, randomly select somebody from that experiment, from the survey. What's the chance, the probability that they liked cheese pizza? So we would say, what do we want? We want the people that like cheese pizza, which is 264 out of the total, 1,000. You could reduce this. You could divide actually both of these by 8 is the biggest number that goes into all of those. So if you're going to write this as a completely reduced fraction, this is as far as you could go with. This is as far as you could go with it. But if you're going to take 264 divided by 1,000, you're just going to move the decimal place 3 spots, because you're dividing by 1,000, you're going to have 0.264 as a decimal. So this would be 0.264, which is the same thing as 26.4 if you're going to write that as a percent. Alright, so this is our final answer. And let's say part B, pepperoni instead now. And so it said the rest preferred pepperoni, so we didn't actually calculate that number, but that's pretty easy to do. You just take 1,000 minus the 264 if the rest of them liked pepperoni, and we put that over the total over 1,000. This minus this is 736 over 1,000, and this you could reduce, you could divide both parts by 8 again. You would end up getting 92 over 125. This though, move the decimal 3 spots, you're going to have 0.736 or 73.6%. And you should notice something. That's a weird looking box, but hey, that'll work. You should notice something here. If you add this number and this number together, you get 1, or if you add this percentage and this percentage together, you get 100%. And that's exactly what it should be, because the total possibilities all put together with probability, it should always add up to 1 or 100%. And so that's something we'll learn about more later, but good little preview of what we'll see in a later lesson. And then finally, I just want to write down a couple of important notes, one important note and then one kind of final definition, and then we'll be all set with this one. So empirical probability. This is the only lesson where we will be focusing on empirical or experimental probability. And so we only use this, empirical probability is used when, generally we only use this when probabilities, when probabilities cannot be theoretically calculated. So like survey results, you can't theoretically say that this many people like pepperoni compared to cheese. You actually have to go out there and do the experiment. You have to do a survey, something like that. But there's a lot of things like rolling dice, like flipping coins, a lot of other things where you can theoretically calculate these things. And then one final note here, the law of large numbers is something that your book talks about, and I think it's important to bring it up here to finish up the notes. The law of large numbers says this, that probability statements apply in practice to a large number of trials. Not a single trial. Not trail. I like hiking trails, but trial, there we go. Not a single trial. It is the relative frequency over the long run, over the long haul, long run, that is accurately predictable. Not individual events or precise totals. And so just to drive this point home, I'm going to do a small experiment here. I'm going to say that I want to roll an even number. That's what I'm trying to get here. So let's just roll the die. I'm going to roll it 10 times, and let's see what happens. And I'm going to keep track of my even possibilities down here. So you don't have to write this down, but let's see what happens. Nope, that was the first one, but I got an odd number. I got another odd number. Even, so that's 1 out of 3. odd, 1 out of 4. Why don't I keep track of this? So we had the total here and the even here. So far we've got just 1 out of 5. We just rolled a 5th time. Another odd, so that's 6th roll. There we go, we got an even, 7th roll. And there's another even, that's the 8th roll. There's another even, that's the 9th roll. And there's another even, that's the 10th roll. Let's do a couple more here. We got another even, that's 11th. Come on, even, there we go. This will help drive my point home. Okay, so I didn't like that it was exactly a certain number equal to a certain number. So suppose we just did this experiment. So you don't have to write this stuff off to the side down here, but do write this down. This is the last thing. So for example, if rolling a fair die, which is what this is, the computer has an algorithm that rolls this die to be fair, quote unquote, where each number has an equal likelihood of being rolled. So if rolling a fair die, you may end up getting, here we got 7 out of 12 being even. 7 out of 12 rolls being even. But the law of large numbers, what does this state in the context of this problem? But the law of large numbers, it would state, so over the long run, the average will be 1 out of every 2 being even. So here 7 out of 12 is does not reduce down to 1/2, but over the long run you would get the average results, or over the long haul the likelihood is 1 out of every 2 is going to be even. Okay, so we're stopping there, we're done, and we'll have some problems to work on in class. Let me know if you have questions about the notes in class, and hopefully you found that helpful as we start our investigation into probability, chapter 12 here.